Hi again. Now we're talking about control charts and run charts. Another problem solving tool that we're going to talk about it in this video. In control charts, it's a chart with a center line showing the average of the data produced. And it has upper and lower control limits that are based on statistical calculations. It is used to determine process centering and process variation and to locate any unusual pattern or trend in the data. So what we've learned about the control chart, that this is a chart that has a center line in the middle and has an upper control limit and a lower control limit. So this is the upper control limit and this is the lower control limit, and that's the average line. And we look into the data, we plot the data, and we look into the data, and the data has to be within the control limits, the upper and lower control limits. If it's exceeded the upper control limit, that means the process in control. Same thing, if it's exceeded the lower control limit, that means the process is out of control. There will be 2 chapters talking about this. So we're going to spend more time on the control charts. But what I want to talk about it today, and I'll give you an example on it, something similar called the run chart. The run chart is similar to control charts. They follow a process over time. Time values are reflected on the x-axis. The y-axis records the data being measured. So the run chart, it's based on time, data with a time. This is what you want to differentiate the run chart from the control chart. The run chart is very good at reflecting trends and the measurement over time. All right, let's take a look into the control charts. This is a sample of control chart. We have a upper control limit up here, lower control limit. This is the average output, the average output. And now for the run chart, you will see that there's the time on the x-axis and the complaints or the defects on the y-axis, and you will see you run a chart based on the data that you have. All right, in order to create this, let's take a look into the Excel sheet that I have, that I want to share it with you here in just a second. All right. Okay, so this data basically, I'm going to delete this so I can show you how to create this. So in this data, it's a data for the number of defective phone chargers. So it is a real data from a mobile company, a phone company, and they're going to inspect the chargers. And what they found, over 1,000 units, they found on week 121 is defective. 131 in week 2, 132 in week 3. So we have a data for 30 weeks, and we listed down the defective parts. And here on the right side, you will see that column, the mean column, which means the average of all these data. And what I did in order to calculate this average, I said equal average. I used the function average, open the parentheses, and now select all these data here and close the parentheses. Before you close it, put the $ before and after the letter, so you could log these data so we could use them for the rest of the cells. So we did use that. So you double click on that, and that will copy everything. So we have the data. This is based on observation. This is the number of observation, the number of weeks, week 1, 2, 3, all the way to 30 weeks. And on this column, on the right column, these are the average of the defects. Now it's time to create the run chart. Select the data, go to insert. On this chart, select the line with marks. And now charger, we give a title, charger defects. And now what we see, do we need to put the mean here? Well, you could put the mean, you could put the mode. It depends on what you want. They're either one could be fine. Maybe you don't want the whole thing. The mean you don't want it. It's just this is the most important thing. So all you need to do is look into the chart and start interpretate the chart. We need to look into the chart. As you see, I'm gonna undo this, bring this here, and what I see, there's a uptrend here from week 9, I believe, starting from actually from week 7, started from week 7 all the way to week 17. There's uptrend, which means there's a shift in the process. We have to investigate how this has happened and what is happening right there in particular. Because it's a source of variation. It's not going to tell you that the process is not stable, and the process start to shifting upward, and we need to keep the process in control. So another problem solving tool that will help you to understand the the data based on the time, and this will give you an idea on the variation of the process or not. With that said, I would like to thank you so much for watching me. And that would be the last problem solving that I will be talking about it. The rest of the chapter will be covered about the rest of the steps for problem solving techniques. We will continue on the PDSA dimming cycle, and we will talk about these details. So now we're going to move to the next phase. See you in another video.